Hey, I'm going to show you how you can make a custom API that does whatever you want on the Solana blockchain. It's really simple. All we need is a way to make a custom transaction, define what the instructions are in that transaction, sign the transaction, and send it. This is all as simple as a single Node.js script, or in our case, a TypeScript file. We're going to do this with a serverless function. So a serverless function, if you don't know, is a bunch of code that lives on AWS or Vercel on Cloudflare. Because it's serverless, it doesn't cost you anything to just have the function exist. You only pay per run. So if you run the function, let's say 1,000 times, you're gonna pay for 1,000 runs of the function. Most of these services like Vercel and Cloudflare, they have really large free tiers, so you can run like 1,000,000 serverless functions a month for free. So effectively, you have your own API that does whatever you want on the Solana blockchain completely for free for a long time. You're going to need three things. First, you got to have Node.js. I've got the LTS version installed that comes with NPM, so you're good to go there. We're going to use the create next tab command to create a boilerplate for all the necessary stuff. This is just going to create a standard Next.js application. We will be using TypeScript, and if you don't know how to write TypeScript, don't worry about it. It is the exact same thing as JavaScript with just a few tiny things added in. I'll walk you through whatever way they're adding. Finally, you will need the Vercel CLI. This is so you can actually deploy your application to Vercel. The setup for this is pretty straightforward. You can use the Vercel docs, and I highly recommend the docs for anything you get stuck at. They're really helpful. I use the docs to actually figure out how to build this. Once you have the create next app set up, you're going to need to add two things. First, you'll have to add a .env file. This is going to contain your Solana secret key. So this is the key for the wallet that you'll be sending the SOL from. Next, you'll have to add an API route. So we are using the app router, not the pages router. In the app router, you've got an app folder. You'll make an API folder. In the API folder, you'll make a send SOL folder. And in the send SOL folder, you'll make a route.ts file. And this file is all we care about. This is where all our logic is going to sit. Everything else, we don't care about it. Vercel cares about it, but we don't care about it. Cool. Before we jump into the actual code, I'll just walk you through what it does at a higher level. So what we're doing in this file is sending SOL to another account. We're going to be doing the regular Solana web3.js imports. We'll be loading in our key pair from the env file. We'll be checking our balance, and then we'll be doing the actual transaction sending stuff. Now, the important thing I want to mention here is this setup is universal. Almost anything you want to do on Solana, you're going to need to do this. Everything else after this, the actual transaction flows, what you do in the transaction, whether or not you even send a transaction, that is custom. It's up to you. You can do whatever you want, but these are pretty much universal. All right, let's jump into the code. First thing you'll notice is the next response and the next request imports. These are really important because this is what exposes the API request to us. We're going to be using the next request object to destructure the body of the API request, and I'm getting out the recipient address and the amount over here. Again, since you're the one that's both creating and consuming the API request, you can have whatever you want in here. Maybe it's a wallet signature, maybe it's a partially signed transaction. Whatever you want to do with your serverless function, you can put in here. Cool. Then we've got the Solana web3.js imports, pretty standard stuff. We're then getting the secret key from the env variables, nothing surprising, and then the actual body of the entire serverless function. The first thing we want to do here is check if this is a post request. If this isn't, we just give him a 4 or 5. Get out of here, brother. You're not allowed to do anything other than a post request. We're wrapping this whole thing in a try catch block. So in case something breaks, we want to know what's going on. Send that back as a 500. Something went wrong. Here's the error. Take a look at it, brother. Cool. Then the actual body of the core body of the serverless function. As we previously saw, I'm destructuring the request to get out the recipient address and the amount. And what we're going to do is we're going to validate as early as possible. This is because the cost of serverless functions is based on the runtime. So the longer a serverless function runs, the more it costs you. So we want to validate as early as possible so we can exit as early as possible. So we don't, end up spending a lot of money and a lot of time for stuff that never ran. So we're going to validate that this is a valid key. If it isn't, sorry, invalid address passed in. Next, we're going to set up a connection. I'm doing this with the devnet. You can change this to the mainnet if you want. And then we're going to get the balance. Again, do a bit of validation, see if there's enough SOL in there. So sender balance should be less than the amount we want to send. If it is, cool, let's go onwards. Finally, we have the actual instructions themselves. So this is just a standard system program.transfer instruction. I've got a transfer instruction here, the address I'm sending from, the address I'm sending to, and the amount that I'm sending. Again, this can be whatever you want it to be. Maybe it's not a transfer function, it's something else. I'm doing a version transaction, so some pretty straightforward message 0 stuff here. Cool. Finally, we'll send it and we'll send it off. I'm doing a maximum of 3 retries. You can up this if you want to. And then with the confirmation, we're going to get the signature. And if there is an error with the confirmation, maybe you're getting rate limited with the DevNet endpoint or mainnet endpoint, we want to send that back. Let the user know, hey, the API request failed. If not, cool, we're good. Let's send it back. This one, yeah, status 200, success true. Give them the signature. If they want something to do with the signature, they can look at it, appreciate it, make love to it, whatever, man, up to them. We're also logging it in the console. This is just for the client, for the server side. This is not going to go to the client. It's Gucci. And that's really it. We're done. I've already talked about the error, and we're good to go. This is our entire serverless function. Let's actually do this. Cool. So we're going to do, what do we want? We want npm run dev. So I'm using pnpm run dev. And we will be using Postman. So if you know Postman, Postman is a way to test APIs locally. So we've got our server ready. So I've got Postman ready as well. And the route that we declared here was API send sol. So we are going to use that exact route. So API send sol. In the body, I've got the recipient address and the amount I want to send. So this amount is way more than the actual wallet has. So we're just going to click send. And we should get a insufficient balance response. Yeah. Success, false, insufficient balance. And we can see over here, we should have had a hit. So it was, we had a request for send sol, and we're good to go there. Big int, this thing, you can just ignore it. Don't worry about it. And that's it. We're basically done. That's all it is. I'm going to actually reduce this to do a couple more things. So this is going to be a successful request, hopefully. One thing you do need to know is we're doing this on the serverless infrastructure on Vercel, not the edge infrastructure. So edge and serverless are two different things on Vercel. The difference between edge and serverless is that serverless takes a bit more time. It's called a cold start. So you can see over here, our request took 3.95. Basically, it took 4 seconds. So on serverless functions on Vercel, there's a bit of a boot time, a cold start. I'm okay with this. I don't need my request to go off instantly. If you do, you can change a few words from the edge network. So you can, instead of selecting serverless function, you can just select edge. There's not much change. It's just a bit of Vercel change. So right about here, instead of importing next server, you import some other stuff for edge. And that's really all that changes. Edge does cost more. So the reason I haven't gone for edge is because I don't need it to be extra fast. I don't really care if it takes 3 or 4 seconds, and I don't want to be paying Vercel money. That's pretty much it. To actually deploy this, again, you just use the Vercel CLI, so you just do Vercel dot. I've already deployed this, so it's just going to ask me, do you want to update this, blah, 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 blah. I don't know why it's deploying. Yeah, it's there. Cool. And to actually test the deployed function as well, you can do the exact same thing. Just change the URL from localhost to whatever your deployed function is. So I've got serverless sol, and the body remains the same. Let's change it up, you know, why not? This is my wallet anyway. And again, same thing, it's going to take about 4 to 5 seconds. And there we go, 4.31 seconds. I think subsequent requests are faster, so let me test that. Yeah, so subsequent requests are faster. Once the function has been booted up, the subsequent requests are faster. And there we go. I just devoided myself of a bunch of sol. That's it. You've deployed your function. And now you have a custom API that does whatever you want on Vercel. One thing worth mentioning is that the Web3.js library on Solana uses certain utilities in the JavaScript runtime that are available in Node.js and in the browser, but they might not be available in other runtimes. For instance, Cloudflare workers, that is Cloudflare's version of serverless functions, they run on the JavaScript v8 runtime, and it does not have access to certain utilities like buffer. So if you run this exact code on Cloudflare workers, it will not work because they don't have certain things available. So please don't try to make it work. I wasted like 2 hours earlier today. AWS and any other platforms that support the Node.js runtime specifically, you're good to go, they'll work fine. So Vercel is good, AWS is good, Cloudflare workers are not gonna work. Finally, when you've actually deployed, you will need to set the secret key on the environment variable. So head over to the Vercel dashboard, select the serverless sol project, the environment variables tab, add in the secret key exactly as you have the variable in there, and make sure you don't have the square brackets here. So if it's got square brackets here, click save and you are good to go. The code for all of this is in the description. I've got a GitHub repo up there. Feel free to ask me any questions in the comments or open up issues on GitHub. I'll try my best to respond in time. If you have any other ideas, things you want me to build, things you want me to make, things you're confused about, stuff that just does not make any sense because you use too many big words, let me know. I'm going to explain it. I'm going to try to explain it like I'm having a conversation with you. Good luck. I'll see you around. Focus, focus, focus. You piece of focus. Come on, man. Focus on my face. Thank you. Cool. Okay.